translation. This is the movement of a point or figure from a place to another on a straight line. Full stop. Now, reflection itself is the image that shows the likeness of an object, just like standing before your mirror. Now, under this translation and reflection, there's something we are encountering, which is a very key word and term, displacement vector. And what is displacement vector? Displacement vector, here in this context, is the vector representation of the distance and between the derivation and translation of an object to the image. We are talking about the vector representation of the distance and direction of translation of object to image. Now, let's go to understand what we are talking about. Let's take an example. For instance, the vertices of a quadrilateral ABCD have the coordinates A to be -1,3, B to be 1,4, C to be 2,3, and D to be 1,2. Now we want to determine the image of quadrilateral ABC under the translation for column 2. Why do you have translation for column 2? Every of these coordinates given have to be represented as a value for calculation. So in that case, we have to represent them as a column matrix under the calculation. Now, what are we targeting here? We have the question saying, so determine the image of quadrilateral ABC. Now, remember, for us to have the image, we must have an object. Also under this topic, remember, we're talking about a particular term, displacement vector, which is what? The distance from the and direction from the object to what? To the image. Now, therefore, we are talking about initial position of objects. There must be a displacement vector or a translation or distance between the object and image to the new position of the image. So therefore, let's now begin to see what we're talking about here. First, we need to begin to see from each vertex. We have vertex A, which we are going to write as a column vector -1, column 3, -1, column 3, as in the order of x, column y. Therefore, we have our distance apart, which is 4, column 2. So therefore, what are we supposed to have now? As we have this, so to get this, notice what we indicated here. Initial position from plus the distance to the new position. You saw we have to get together to get our new position. So which means we are going to be having our -1, column 3, -1, column 3, to be added to our 4, column 2, 4, column 2, which will give me what is going to be my image now. Now, my image is going to be for the image of A, will be A prime. What is that? Okay, let's have it here. To map onto A prime. And that will give me -1 plus 5 plus 4. That will be 3. 3 plus 2, that will be 5. Okay, that means that we have 3, column 5. Now, let's go quickly to get what's going to be our value for vertex B. Vertex B, where we have 1,4, will be represented as 1, column 4. Now, 1, column 4, we also have the effect of 4, column 2 at the distance apart, so adding it together. Now, by the time we are adding this together now, in this case, we'll be having, this is 1, column 4, adding to 4, column 2. That's 1 plus 4. In this case, we have B, image of B as B prime. The image of B as B prime will give me my 1 plus 4 as 5. My 4 plus 2 as 6. So the image of my B will be at 5, column 6. Let's get to note the one of C. The coordinate of C, which is what? 2, column 2,3, to be written as 2, column 3. To be added to the same distance apart or translation or displacement vector. And that we map onto, okay, let's check it. 2 plus 4, to give me that image, we have 6. Then 3 plus 2 will give me 5. So the image of C, we have it now, C to give us 6, column 5. Now for D, where D is 1, column 2, to be added to the displacement vector, which will now give me 5, column 4. Now, looking at it now, our objects from what we have initially, -1, column 3, 1, column 4, 2, column 3, and 1, column 2 for A, B, C, D respectively. So on the image now, we now be having A image of A 3 column 5, image of B 5 column 6, image of C 6 column 5, and image of D 5 column 4. What do we mean? Let's translate this to the Cartesian plane. Yes, this is our Cartesian plane. Our first one given to be the original object A minus 1 column 3. This is minus 1 traced to 3, which will be around this place. Okay. Next one is 1 column 4. This is 1 on the x-axis to 4 on the y-axis. That is this place. Okay. Then our 2 column 3. This is 2 of x here, traced to 3 of y around this place. Okay. That will be here at 3, where we have 3 to this place and 2 to this place. Now, this is first one, this is A, this is B, this is C. Now, our D, which is given as 1 column 2, my 1 on my x-axis, and my 2 on my y-axis, which will be around somewhere around this place. So, therefore, this will be my D. Let's now join it from A to B, from B to C, from C to D, from D back to A. That is the quadrilateral given to us. Now, let's now go and check for the image. A prime will be 3, 5. This is 3 traced to the location of 5, which will be around this place. So, our A prime is somewhere around here. Now, let's get our B prime. B prime is given to be 5 column 6. This is my 5 traced to 6 on my x-axis, which will be somewhere around this place. So I have my B prime at this location, trace down to my 5 and traced to my 6. Alright. Our C prime 6 column 5, 6 on the x-axis and 5 on the y-axis. Here it's 5 on my y-axis. I will trace to 6 on my x-axis, which will be something around this place. So I have my C column 5, C here, prime here, that is 6 column 5. Then for my D, which is D is 5 column 4. So I will come here from this place, which is already on my x-axis here. Then to my y-axis 4, I will trace it along the line, along this line, which crosses at this point. So by the time I join my, this be my D prime. By the time I join my A to B, I join my B to C, I join my C to D, and D to A. So look at it. What do we have? A translation of my object to image. What just happened? Moving this object from this initial location to this location is a translation. This is a translation from here to here, mapping D to the image of D, mapping C to the image of C, mapping B to the image of B. So this is my translation. The movement of this object to this image is my translation. Whereas I have an object and an image, which indicates that I have a reflection of my object. So that's why we are taking together translation, which is a movement away from a place to another place, and the reflection, the image of an object. Thank you. Here, a reflection is the image you see when you look in a mirror. The line of the mirror is a line of symmetry between the object shape and its image. Meaning, look at this P that we're being given here. Yes, you can see the P, which is this first one, and its image. So the center, the middle between them, is where we have the line of symmetry, acting as what? Surface of the mirror, or the mirror line. That's what we mean as the line of the mirror. Also, I want to take a leaf from some of the things here. Take, for instance, this a triangle. So the line of symmetry running downward will act as what? Surface of the mirror, or the mirror line. And you know, when you stand before a mirror, your distance from the mirror to where you are is the distance from the mirror to where your image is formed. So meaning, when the line of symmetry is coming, it is exactly at the middle distance between the object and the image. So every line of symmetry is expected to divide an object or a space given into two equal parts on this side. Now, if I have an object or a point P here, this is my original value for P, for the reflection in x-axis, meaning I'm taking it respect to x-axis. If this is my mirror surface, this line of x is my mirror surface, this is my object, then my image will be casted behind the mirror. So therefore, my P will be formed somewhere around there, here. And note, the distance from here to here is meant to be equal from this distance from here to here, meaning this place and this place are meant to be equal. Change in x here as positive, and my change in x as negative, they are meant to be change in x positive equivalent to change in y negative. So the unit taken here must be equal to the unit to this side. So this is my mirror surface, or my line of reflection. So whatever distance I have away from the positive side of x of y should be the same distance away. Ditto to what I should be expecting on this side. If this point I'm taking the reference to my y-axis, if my y-axis is the mirror surface, so I will take the distance from this place to P. Remember, the distance you have to your mirror will be the same distance your image will be behind the mirror. This is the first image on x-axis, and this is my second image to y-axis. That's what I'm naming it P prime prime. So meaning this will be change in y, and this will be a negative change in y. So a positive change in y equivalent to, so meaning the reflection in x-axis will be considered by taking the distance with respect to what? Y-axis. While the reflection in y-axis will be taken by considering distance covered in the x-axis, meaning from here to here, which is the change in x negative. And also the same thing to this place, which is from here to here, which is the change in x positive. Therefore, my positive change in x is also equivalent to negative change in x. For reflection in x-axis, remember, positive change in y equivalent to what? Negative change in y, meaning the displacement away from the line of x-axis towards positive y is equivalent, or the same unit to the towards the negative of y. And the same thing here, if I'm considering my P to the y-axis as my mirror surface, the distance away from y-axis will be the distance away from y-axis towards the negative of x. So the distance will be considered on x-axis, positive, negative, for reflection in y-axis. But for reflection in x-axis, it will be considered, the distance will be considered on y-axis, and y-axis positive and negative side. Now, if peradventure I have my x and y as a graph of y equals to x, meaning for when x is 1 and y is 1, x is 1. When y is 2, x is 2. When y is 3, x is 3. That will give me a straight line running in diagonal form this way. So for a line running this way, how will I have my reflection if this line of y equals to x is considered as my mirror surface. So if I have a point here as my P, this will go toward this side as x comma y, towards the x, towards the y. By the time this distance to the given straight line, which is the line of y equals to x, the same at this point the line have to be at right angle, and the image will be the same distance, just like you have P here. So this is going to be my P prime, also at. So what will happen at this time, whatever is my value for x here will interchange. It will interchange. So therefore, if here I'm having 2 column 4, by this place I'll be having, can you notice it, 2 column approximately 4. So here I'll be having, here it is 2 column 4, but here it will be 4 column 2. So here where I'm having x column y, which is 2, x comma y, which is 2 comma 4. Here now I'm having 4 comma 2. This is supposed to be my x, this is supposed to be my y. But now I cannot write it that way because I have x comma y as my represented vector quantity, x comma y here. Then my image now in this case supposed to be x prime comma y prime. But in this case now, my x prime here, which is the value of x at the image, turn out to be the value of my y, which is going to give me y, and my y prime here, which is supposed to be the y for my image, turn out to be the value for my x at the object. So where my y prime equals to my x, I can relate it as well to my x. Now my x prime turn to be the value of my y, the y of my object, and my y prime, which is the y of my image, turn to be the value of my x of the object. So in this case now, we say when P turn out to be maps onto the image for, when P turn out maps onto the image for the equation of line y equals to x, then this we have x column y we map to give me y column x. Remember, this means x prime y prime. So the x of my image is representing the y of my object, meaning the value of my x for the image will become the y of my y for my object, and the value of the x for my object will turn out to be the y for my image. That's why we are interchanging this. Now consider a situation where the line we are drawing is now the line of y equals minus x. Yes, a line of y equals to minus x. That's how to represent it that way. Now if I have this kind of line, okay, and I have an image somewhere here, and the image is coming toward this place at 90 degrees. Tracing this to my, I have x. If I trace it here, I will have minus y. Oh, I don't want to consider that. Oh, what else will I consider? Because if I come here, I'll be having a point anywhere here to give me y to be positive, x to be negative. So how do I get that kind of value here? So if I have a point here, a point P, so at this point x will be positive, a positive x, and y will be positive, a positive y. So therefore, if I want to get the image of that my P, it can only be from here to join to this line at 90 degrees. So the distance I have from here to here, I must keep the same distance at the opposite side, which will come to this area. So my P prime will be formed here. So if my P prime is formed here, remember, something will happen. If I trace this to be my negative x, if I trace it to be my negative y, and don't just only notice that if I'm making a proper graduation, let's take a proper graduation here, 1, 2, 3. So here I have 1, 2, 3. Let's have 1, 2, 3. Now I'm having 1, 2, 3, 1, 2, 3, minus 1, minus 2, minus 3. Okay, now at this point my x comma y will be written as x column y for my P, and here I have P into what is the coordinate of what I have here, minus x prime and minus of y prime. Okay, or let me say it's my x prime and my y prime. Now let's now go here. My x is 3. My x is 1. My y is 3. By the time I trace to my image here, my P prime at this junction, this is the point here, I will discover that my x is minus 3 and my y is minus 1. Something happened. My P supposed to map to my image where I'm having 1 and 3, now mapping onto minus 3 minus 1 as my vector representation here now. So something has happened. Where I have x here, I'm having the same, supposed to be x prime, but my x prime is equivalent to my negative value of my y. Remember, this is my x, this is my y for the objects, this is my x, this is my y prime for the image. So my x prime turned out to be a negative value for my y, and here my y for the objects is supposed to be y prime, and my y prime in this case is minus 1, turned out also to be the negative of my x of my image, meaning I'm having negative of x. So instead of having my x y for my object to map onto my image, in this case as x prime y prime, again I'm having x y mapping onto minus y minus x in this case. Now if you have been following, you will notice that all I have done in those examples so far, in x-axis, x column y for my object mapping onto my image, it maps out to be my x remain but minus y happens. For the reflection in y-axis, I have x to y mapping to minus x and y. For the reflection in line y equals to x in that equation, I have a situation where x to y only interchange to y column x, whereas in the case of the reflection in line y equals to minus x, we have s column y giving me minus y minus x as the reflection. Now, this is a summary of what you have in reflection to your x axis, to your y axis, to y equals to x, and to y equals to minus x. This for this, this for this, this for this, and this for this. Now let's work this example together. Let's work what we have in example 1 here. It says that if a point x has the coordinate 5, minus 2, find us the reflection in x-axis. Oh, the coordinate as 5, minus 2. So where p equals to 5, minus 2. P is given as 5, minus 2. So therefore, the matrix representation will be 5, minus 2. Remember, in x-axis, we have x, y to map onto x minus y. So therefore, our 5 minus 2 we map onto 5 minus 2, which will give us 5, 2. Can we see that? Yes. Now that is for A. For the B part, we were told to find the reflection in y-axis. So in y-axis, x column y, we map onto minus x and y will remain. So therefore, our 5 minus 2 will give us minus of this to minus 2. So because 5 has no is positive initially, so it will not have any sign affecting it, unlike what we had here. Now for the C case, now where it is stated that what are we going to be expecting if, what will be the reflection if P is having its reflection in the line of y equals to x. So remember, x, y in this case turn out to give us y, x. So therefore, our 5, 2 will give us 2, 5. It's easy for us to just get the coordinates or the vector representation even without going to the graph board or graph sheets. Now the last one, what is expected to get? What is the reflection? What will be the reflection? What point will be the reflection in line y equals to minus x? Remember, that one looks as x column y to map onto minus y minus x. Yes, that's what we are supposed to get. So therefore, we have our 5 minus 2 to map onto minus of minus 2, then minus 5. Minus. So that will give me 2 column 5. Yes, that's all the solution there. I believe you can see it everything clearly there. That's an example. Now let's now talk about rotation. From our notes, rotation is another word for turning, as shown below in the diagram. And this rotation we are talking is when the image is another form of translation. First of all, is when the image is translated about a fixed point. What's our fixed point? In this case, origin 0 is our fixed point, and P is turning about the fixed point, meaning it's still turning, but its source fixed to what? 0. So the displacement from 0 to this place will remain from here to here. So we have about 1, 2, 3, 4, 5, 6 unit away. 1, 2, 3, 4, 5, 6. Okay, we just have that P translating this way about a fixed point. Now, if it is turning or rotating away, it will be turning in degrees. So, if it is turning in degrees, now it is turning away from here toward this side in theta degree. Notice something we have to pay cognizance to, that when we have our points rotating about a fixed point, one, there must be a center of rotation. In this case, our 0 is a center of rotation, but it may not be center of rotation in all cases. Some will be rotating about a fixed point, which will be a coordinate in the graph. But this case, our coordinate is 0, 0. This is the center of the graph. Now, here, 0, 0 as the coordinate here. As here I have x, y, and this will be x prime, y prime. I believe that is clear enough. Now, note, don't consider it negative. But in this case, let's go on this way. That when it is turning, at every special angle turning, when it's immediately plus a special angle, there's an expectation. Look at this. 90 is a special angle. 180 is a special angle. 270 is a special angle. So if I have my point P at x, y, meaning x is positive, y is positive, it's on the positive side of x and y. Taking a quadrant, for instance, is on the first quadrant. For it to turn 90 degrees away, that means at that point it must have gotten to the second quadrant, which is supposed to. Here is what I'm talking about. If this is my P, it's moving to this position as the first image, now moving to this position as the second image, and moving to somewhere around this place as the third image. Okay, let's now look at this. P here, x, y. So giving me x column y, everything positive. At this place, x become negative and y become positive, where we have minus x and y. But something is going to happen here, because if you remember our reflection in this case, when we talked about reflection, that if a reflection is coming toward this side, there will be interchanging here. Where we have our x being represented by the value of y and our y being represented by the value of x. Yes. So what is happening now? Where our x is being represented by the value of y now, I will now be having minus of y, because x is replacing y, and I will have what's there, my y replacing my x. I'll be having x here. So therefore, at this p prime of this place, my value here will be minus of y, will be minus of y column x. So for this area of 90-degree turning, for a turning of 90 degree to this point, so my p prime will give me my minus y column x. So I will write it in this place now as p prime will give me minus y column x. But by the time it turns from here all through to 180, at this point here, my p is minus y. My pa is also what? Minus x. So here now at p prime prime, I'm having minus x minus y. But at this junction, remember, our rotation is supposed to give me an interchanging value where my p to p prime prime supposed to have x column y mapping onto under reflection, which we have done, supposed to be mapping onto y column x. But now that it is now coming this way, at this point, this is supposed to happen at the positive, but because it is happening at the negative now, so therefore it remains that at 180 degree, my p prime prime maps onto minus x and minus y at this point. Then if it is turning from this place, from here is turning to 270 degree, so meaning this same point is reflecting to this place, though it is rotating here by angle, but taking this one, we take it as reflection. So the rotation of 270 will bring a reflection in the line of x-axis. Remember, if it is rotation in the line of x-axis, x, y, we maps onto x minus y. Do you remember? Now, in this case now, at this point, what is going to be the value of x? X will be positive, where y is what? Negative. So my x turns out to be positive value, a positive value of x, and my y turns to be what? A negative value of y. So as we have it here, I'm supposed to have my y. Now, not now that my y is already negative here, and my x is already positive, and as a reflection now, I'll be having y minus x. Y minus x. It's going to be y minus x now because my y is interchanging with x as the cause of reflection. Now my y, which is what initially negative, now I'll be having a situation of minus y replacing my x, and the minus of my x, which is already positive initially. So if I'm to sort this now by calculation out, I'll be having negative and negative will give me plus of y, and this will give me minus of x. So therefore, under 270, my p prime 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 image at 270 will be mapped onto plus y and minus x. Thank you. Figure 15.42. As we have there, you can see the real image is that blue color. We have increased it to the A1, B1, C1, D1 for that quadrilateral. Yes, that is enlargement, increasing, adjusting the size. But sometimes I said you cannot adjust, you cannot increase, but instead we reduce, and that diminishing of the image or the image of the object is also part of the enlargement we are talking about. Why is it part of the enlargement? Because at the time there's a place of focus where you sight all the image, the object, and even the diminishing one. That's how we notice our enlargement. So that focus, that point where you sight the image of the object, both the diminishing image and the increased image as enlargement, that point is the center of enlargement. Enlargement. What do I mean? Look at this. Yes, this is the real image. This is the real object. See a diminishing image. See an increased image. This point O is our enlargement. Is our point center of enlargement. Sorry. This point O is our center of enlargement. So what we have here will be what? Reflected back as image, as point O serve as a point of enlargement, center of enlargement. Now, let's go to what we have in the example here. It says, triangle P, where we have P as 1,6, Q as 5,4, R as 3,2. In this triangle now, it is mapped onto its own image. Another triangle where P prime is -2, -6, Q prime is -4, -5, and R prime is -3, -4. We are talking about example 5 on page 179. Now look at this drawing, the graph of that drawing. This is the real triangle as given. Now this is the translated image. Looking at it, we already know that what it is reduced, but still under this condition we call it what? Enlargement. Where is the point of enlargement? As we are given from the question, it says now let's find the coordinate of the center of enlargement and the scale factor. Oh, that scale factor is giving us the value of our increase. Let me call it that way. A value that determines how you increase or reduce. That is more or less like saying the magnification. Either you are magnifying, you are increasing the what do you call it? The size, or you are reducing the size. The magnification. Now, at this place, let's now first of all go to the first one, where the center of enlargement, that is point C. At what point is that? Tracing to the x-axis, that is -1, to y-axis, that's -2. So the center of magnification is -1, -2, x, y, x, y, -2, -1, -2. Now let's now talk about the other side, where we're talking about the scale factor, meaning our magnification. How do we get our magnification? We compare or find the ratio of the real image, the real object, to the image. Now look at this. We have to take the measure of C to a vertex of the object R, and the measure from C to a vertex of the object, a corresponding vertex of the image. Now we choose vertex R, so we are measuring C to R. So we also measure C to the corresponding vertex that we have chosen before, which is R prime. So we are taking the measure to the image over the measure to the object. So C to R, that's why we have our CR here over CR, CR prime over CR. So our CR prime, by calculation using Pythagoras theorem, taking the difference in x and difference in r as our opposite and adjacent, to find the hypotenuse, we have -√8. Then to get that of C to R, taking our adjacent and opposite to find our hypotenuse, we have √32. So therefore our magnification there will be √8 over √32, and by rationalizing that we have -2 √2 over 4√2. Eventually -2, we cut -2 out, and 2 is still common between to 2 and 4. So cutting that through, we have -1 over 2. Thank you. God bless you for listening to this class. See you another time.